Okay, this is College Algebra, Unit 1, Note 7, Solving Linear Equations. So first, starting off with some vocab, we have an equation, and that is a math sentence with an equal sign. So for example, x squared plus 5 equals 7, an equation. A linear equation, so what we're going to focus on today, is an equation where the variables have an exponent of 1. So it still has that equal sign, but we're only dealing with a variable with an exponent of 1. So in our example, we have x plus 5 equals 2. A solution is a value that makes an equation true. So this is important because our solution, if it makes the equation true, should be able to plug back into our original problem and get a true statement. So a true statement is where a number is equal to itself, like 5 is equal to 5. And then lastly, we have inverse operations. So inverse operations just means the opposite operation. We need to know the inverse operation in order to move a number or variable to the other side of the equation and ultimately cancel it out. So the opposite of adding is subtracting. The opposite of subtracting is adding. The opposite of multiply is divide, and the opposite of divide is to multiply. So now let's look at the steps on how to solve linear equations. So our first step is to simplify each side. And what I mean by simplify is you're checking these two things. Do you need to combine like terms, or do you need to distribute? Okay, or maybe you need to distribute and then combine like terms. Okay, each side, so both left and right of the equation, must be as simplified as possible before you start manipulating it and moving variables and numbers to either side of the equal sign. Step 2 is to move the variables x to one side and the constants, which is a number, to the other side. Our last step is to check our solution. So let's look at an example. We have x plus 7 equals 15. So before we start, I'm going to go ahead and draw a vertical line down at the equal sign to illustrate that we have two sides, the left and the right side. Our goal is to get the numbers to one side and our variables to the other. Well, since our variable x is already on the left, I'm going to say that the x variable needs to stay on the left, which means I want to move all my numbers to the right. So I need to get rid of that plus 7. So I think of the inverse operation of adding, which is subtracting, and I'm going to subtract 7 to both sides. When I do that, the 7's cancel out, and the x is going to come down, and I have x is equal to 15 minus 7, which is 8. I then need to check my answer. So I have x plus 7 equals 15. But I said x is 8. So 8 plus 7 equals 15. 15 equals 15. This is a true statement. That means I did my math correctly. Okay, let's look at another example. Okay, so on this example, I have 4x is equal to 28. I'm going to draw my line down the equal sign. My x is on the left, my numbers on the right. Okay, so since 4 is being multiplied by x, I need to divide, which is the inverse operation of multiply, both sides by 4, which means the 4's will cancel out. I bring down the x, and I get x is equal to 7, 28 divided by 4. So I check my work. So instead of saying 4x equals 28, I plug in 7 for x, and I get 4 times 7, which is 28, so 28 equals 28. Okay, true statement. I did my work correctly. Okay, number 3, notice that we now have more terms on the left side. We're still going to have our x's be on one side and our numbers on the other. Okay, but notice we have 3 times x plus 5. Anytime we have more than one term there, we always want to get rid of the adding or subtracting first. So I'm going to subtract 5 from both sides. The 5's will cancel and the 3x will come down. So I have 3x is equal to 20 minus 5, which is 15. Then I can divide by 3, and I get x is equal to 5. So I'm going to check my work. 3 times 5 plus 5 equals 20. 3 times 5 is 15. 15 plus 5 is 20. So 20 equals to 20 is a good statement. It's correct. It's true. Okay, let's look at number 4. Now we have 2 times x plus 4 equals 18. So this is where we go back to step 1 and see that we need to distribute before we can do anything else. So we have 2x plus 8 equals 18. I'm going to subtract the 8, and I have 2x is equal to 10. Then I divide by 2, and I get x is equal to 5. So I check my work. 2 parentheses 5 plus 4 equals 18. Remember, this used to be my x. And so I have 2 times 9 equals 18, following order of operations. So I have 18 is equal to 18, which is a true statement. Okay, now let's look at number 5. We're getting a little bit more trickier as we go. So first, before I do anything, I notice that I have lots and lots of things going on the left side. So I'm first going to distribute my 3. So I have 3x minus 6, bring down that x, equals 18. Now I need to combine like terms. So 3x plus x is 4x. Bring down the minus 6 equals 18. Now I can start solving. Add 6 to the other side, and I get 4x is equal to 24. Divide by 4, and I get x is equal to 6. So because this is so complicated, I want to make sure I did my work correctly. So I'm going to go over here, and anywhere I saw an x, I'm going to plug in a 6. So 3 times 6 minus 2 plus 6 equals 18. Following order of operations, I have 3 times 4 plus 6 equals 18. 12 plus 6 equals 18, which leaves me with 18 equals 18, which is a true statement. Let's look at the next example, example 6. So now, not only do I have multiple things going on each side, I also have a variable for the first time on both sides. So remember, I want to try to always put my x's to the left side and my numbers to the right. If you end up switching them, that is okay. You will still get the same answer. So if I want to move all my x's to this side, that means I need to move this 2x over. So this 2x is a positive 2x, so I'm going to subtract 2x. The 2x's cancel, the 19 comes down, the 7 comes down, 4x minus 2x is 2x. Bring down our symbols. Now I can subtract 7, 2x is going to come down, 19 minus 7 is 12. Divide by 2. X is equal to 6. Okay, let's check my work. 4 times 6 plus 7 equals 2 times 6 plus 19. Well, this is 24 plus 7 is equal to 12 plus 19. Which is 31 is equal to 31, a true statement. Okay, last one, number 7, we're bringing back fractions. Okay, so our first step is always to get rid of the adding or subtracting. So I'm going to go ahead and add 4 to the other side because that's my opposite operation, my inverse operation. So the 2/3 x comes down, and 10 plus 4 is 14. So now think about this. This is 2/3 times x. So the opposite of multiply is divide. But if I do divide by 2/3, I'm now dividing by a fraction. And remember, anytime I divide by a fraction, that's the same as multiplying by its reciprocal. So really, I am going to now multiply both sides by the reciprocal of 2/3, which is 3/2. These cancel out because what you end up getting is 3 times 2 over 2 times 3, which is 6 over 6, which is 1. So that's why they cancel. And so I am just left with x on this side, and then I have 14 times 3/2. So remember, I have to turn this 14 into a fraction by moving it over 1. And then I can multiply across. Okay, if I don't know what 14 times 3 is, I come over to the side, do some scratch work. 3 times 4 is 12, carry the 1. 3 times 1 is 1. 3 times 1 is 3, plus 1 is 4. So this is 42 over 2, which simplifies 21 over 1, which is just 21. And then I check my answer. So I have 2/3 times 21 minus 4 equals 10. So same thing, I turn that into a fraction. So this is 42 over 3 minus 4 equals 10. In order to combine subtracting fractions, I need to get a common denominator. So for that second one, that common denominator would be 3. So I have 42 over 3 minus, in order to get this 3 on the bottom, I have to multiply the top by 3. So that's 12 equals 10. So I have 42 minus 12, which is 30, over 3 equals 10. 30 divided by 3 is 10, so 10 equals 10 gives me a true statement.